How's everybody doing out there? Well, for chapter 10, we're going to get a brand new distribution. So we've had our normal distribution, which had z-scores. We had our t-distribution, which gave us t-scores. And today we want to talk about chi-squared distributions, which are going to give us chi-squared scores. And so for this one, these are going to be more hypothesis tests that are kind of a multivariable hypothesis test. These are pretty powerful and get used a lot in a lot of different areas of statistics and things like that. So before we get into the different types of hypothesis tests, we want to first learn a little bit about our chi-square distribution and what it's going to look like, and then we'll look at some different types of hypothesis testing that we'll be doing. So if we look at our chi-square distribution, then it doesn't quite look like a normal curve or anything like that. And so what I've got on here are a few different examples with different degrees of freedom for each and every one of them. So the first one that we would have here would be our degrees of freedom is 1. This would be 2, 3, 4, 5, 6, 7, the whole way down to 8. So notice it does get kind of flatter as it goes along, but the majority of the data is always going to live to the left-hand side, and the smaller amount of data is always going to live to the right-hand side. And even if our degrees of freedom get kind of bigger and bigger, it'll never quite get to be a normal curve or anything like that. And so for graphing purposes, when I'm talking about shading and things like that related to our hypothesis test, I'm just going to use the degrees of freedom of 3, just so I have something to sketch and draw with and stuff like that. So we are going to have things just like we did for our other hypothesis tests, test statistics, comparison statistics, all that kind of stuff, just like we had before. So there's just going to be slightly different ways that we actually calculate them. All right, so let's take a look at how we're going to find a p-value for one of these hypothesis tests. So normally we would have used either normal CDF or TCDF. Well, luckily and lo and behold, on our calculator, we've got the chi-squared CDF option, just like we did before. Now, one nice thing about hypothesis testing in a chi-squared distribution is every test is going to be a right-tailed test. So since if we look at our graph, there's a ton of space up here, so we're never going to have a situation to the left where we're going to try to reject H naught. So whenever we're going to try to reject H naught, it's always going to be out here in the smaller section where the graph gets narrower and narrower and narrower. So we don't have to think about whether it's left-tailed, right-tailed, or two-tailed. These are all going to be right-tailed tests, every single one of them. And so when we go to type this into our calculator, then what we're going to do is we're going to use kind of the same model we did for TCDF, except in this case we're going to have our lower bound, which will always be our test statistic. Our upper bound is going to be some ridiculously big number, and then our degrees of freedom is going to be the last number in our list. So again, very similar to TCDF, except we're always going to be using right-tailed. So our test statistic is always going to be that lower bound for these. All right, so when it comes to actually finding like a chi-squared value for a given alpha, so think of this as our chi-squared sub c. So in the past, we've used inverse norm and inverse t. Now, unfortunately, there is no inverse chi-squared on the calculator. So the only way we can actually figure out what our chi-squared comparison value is going to be is by using the table. Now again, since it's a right-tailed test, we don't have to worry about dividing our alpha or anything like that. We can just use our alpha exactly the way it is. And so what I did is a little example here. If we wanted to figure out what the chi-squared sub c value would be for a 0.05 alpha with degrees freedom of 6, then we just kind of highlight the alpha equals 0.05 row. We look at the row of 6, and then that 12.592 would be our chi-squared sub c in that case. So again, unfortunately, there is no inverse chi-squared, so we will have to use our table when it comes time to actually find those and look for them and stuff. All right. So if anybody has any questions or anything about any of the background information, just let me know. Otherwise, I'll see you in the next video where we'll do our first hypothesis testing with chi-squared.